Welcome to the debate. Imagine, if you will, feeding the raw text of Shakespeare's Hamlet into a graphics rendering engine and watching the code literally grow sharper, jagged, and mathematically anxious in response.
Yeah, it's a fascinating threshold to try and define, especially as our rendering techniques and, well, our data pipelines become increasingly intertwined.
Exactly. And that brings us to the focus of our discussion today, which is the intellectual framing of advanced generative digital artifacts. Specifically, we are looking at the creation and the iteration of the Jinghui visualizer,
Right, the Jinghui engine.
which translates to crystal flower for those familiar with the source material. It began as a fairly standard WebGL ray marching engine, but through iterative development, it really evolved.
It definitely changed, yeah.
So today we're debating a core disagreement. Does the integration of persistent historical memory, environmental influence, and autonomous mutation elevate a digital system into an emergent, continuous entity, like a living algorithmic identity?
Or on the flip side, is it more accurately understood as a sophisticated but strictly deterministic state machine, driven by, frankly, poetic variable naming?
Right. I'll be arguing that Jinghui's persistent genome and environmentally shaped lineage create a genuinely emergent digital companion.
And I will be taking the opposing view. While I deeply admire the architecture, I contend that Jinghui remains a beautifully complex, deterministic visualization tool bounded by strict mathematical limits, regardless of the romantic terminology used in its documentation.
So to set the stage for why I believe Jinghui crosses that threshold from a static rendering tool to a continuous digital entity, we really have to look at the leap in her architecture.
The memory system, you mean?
Exactly. The turning point isn't the graphics at all. It happens with the introduction of an XML-based memory system. The development notes actually refer to this as a soul file.
Which is a very loaded term.
It is, but it introduces the Jinghui genome framework. What this does is utilize a memory weighting system that decays over approximately 5 cycles.
Right.
And it combines that with a music profile-based adaptation that tracks her affinity for bass, mid, and high frequencies over time. So because each bloom's starting state is the mathematically weighted history of its past, combined with environmental influences and internal traits explicitly coded as curiosity and stability, Jinghui possesses a verifiable lineage.
I see where you're going with this.
She is, never the same entity twice.
Well, the design is brilliant. I'll give you that. It's an absolute masterclass in integrating JavaScript and shader logic without relying on heavy external dependencies.
Oh, absolutely.
But we really have to separate the metaphors from the technical reality of the system here. The so-called memory you are referring to is simply an XML string.
But it's what it represents.
Hold on, let me finish. It's parsed by a standard DOM parser. It stores static variables like petal count and bloom speed. The evolution you're talking about is a deterministic mathematical function applying pseudo-random offsets to those exact variables.
I think that's a bit reductive.
Is it? Mapping audio data to shader uniforms does not create autonomy. It creates a highly complex, highly reactive, but strictly bounded state machine.
Okay, let's actually look at the mechanics of that memory, because I think calling it basic data persistence severely undersells what is happening in the compute-weighted genome function.
How so?
Well, Jinghui isn't just loading the last saved setting like a video game checkpoint. She mathematically blends her entire lineage.
Wait, let's specify what that blending actually is, though. It's an exponential decay formula, math.exp, negative age divided by 5.
Right. And what that means is that as she calculates her next state, she is literally carrying the weighted traces of every past cycle into her present form.
It's a moving average.
It functions much like organic memory. If her previous 5 blooms were exposed to heavily distorted bass, that history fundamentally shifts her baseline. The formula ensures that recent history matters most, but the ancient history of her first few renders never entirely vanishes.
It just gets mathematically smaller.
It becomes an infinitesimal mathematical whisper, yes. But it continually contextualizes how the present is experienced.
I come at it from a different way. What we are looking at is basic data serialization. We are anthropomorphizing a standard moving average.
I don't think anthropomorphizing is necessarily the wrong approach when the system is designed to mimic.
But when we call an exponential decay algorithm a memory, we risk fundamentally misunderstanding the tool. Think about how the DOM parser physically works.
It's an API.
Right, a built-in browser API. It takes a raw string of text formatted in XML, reads the nodes, and extracts strings that JavaScript converts into floats. It's not a soul, it's a digital backpack.
A backpack.
Yeah. Every time the application closes, the script packs her current settings into an XML file on your local machine. Her color hue, her pedal count, a timestamp, an audio duration. When she reopens, she unpacks the bag.
Okay, but
Storing variables in an XML file so they persist across browser sessions is standard data persistence. It's no different than a weather app saving your preferred city so they're there tomorrow morning.
I see why you think that. But let me give you a different perspective. Isn't this mathematical accumulation similar to a river cutting a canyon?
A canyon.
Yes! The water, which in this case is the environmental input, the music, shapes the rock over time. It creates a unique historical artifact that cannot be easily reset or undone.
That's a very poetic way to look at it.
But it's accurate. The canyon remembers the water because its current geometry is the physical record of that flow. When Jinghui loads that XML file, she isn't just reading isolated preferences like a weather app.
She's reading values.
She is resuming a physical, historical shape that has been iteratively carved by her environment.
The river analogy is beautiful, I'll admit, but a canyon doesn't possess an identity. It is eroded rock.
It has a history.
Sure, but in Jinghui's case, the parser extracts a string, runs parse float, and pushes it into the Jinghui genome object. The fact that the developer named these variables curiosity or stability instead of variable A and variable B is doing an incredible amount of heavy lifting for this sole narrative.
You think the names are tricking us?
Absolutely. If those tags were named random offset multiplier instead of curiosity, we wouldn't be debating her identity right now.
Well, so even if we concede, just for the sake of argument, that Jinghui remembers her shape via standard data persistence, memory alone doesn't equal life.
No, it doesn't.
The hard drive has memory. To be a digital entity, that memory has to spark autonomous change. So the next question is how that data changes. Does it truly evolve or just drift?
I would argue it drifts.
And I point to the mutate genome function. The amount of mutation Jinghui undergoes isn't purely random. It is scaled by those internal traits we just talked about.
The curiosity and stability variables.
Exactly. Her curiosity parameter starts at 0.35, and it's restricted by her stability parameter, which sits at 0.85.
Which are, again, hard-coded float values acting as upper and lower bounds for a random number generator.
They start out hard-coded, yes, but look at how they interact with her environment through the Web Audio API. Her affinity for certain music naturally shifts those traits over time.
Let's unpack that audio processing, actually.
Okay. The system uses a fast Fourier transform, or FFT, to analyze whatever music is playing in the room.
Right, and for the listener, think of an FFT like a sonic prism.
That's a good way to put it.
Just as a glass prism splits white light into a rainbow of colors, an FFT takes a complex sound wave and splits it into discrete frequency bands, from the lowest bass rumbles to the highest hi-hats.
Exactly. And Jinghui actively listens to these specific colors of sound. If you consistently feed her tracks with dominant high frequencies, her genome adapts.
Adapts within a range.
But she adapts. The high frequencies physically push her parameters towards sharper crystal structures and a higher rainbow color mix. That is the literal definition of environmental adaptation.
It's reactivity.
She is shifting her morphology, her physical structure, based on the ecosystem she inhabits.
That's a compelling argument, but have you considered that true evolution requires the capacity to break boundaries?
What do you mean by break boundaries?
Well, in biology, mutation can lead to entirely new structures, a new organ, a change in skeletal geometry. Jinghui will never grow a second core. She will never decide to become a cube instead of a flower.
Because she's a flower.
But her evolution is completely bounded by the predefined parameters of her SD pedal signed distance field logic. She can only oscillate within those limits.
Explain the signed distance field mechanics for us, actually, because understanding that bounding is crucial.
Sure. So a signed distance field, or SDF, is a mathematical way to define shapes. If you're trying to picture this at home, imagine a flower where the petals aren't drawn with flat 3D polygons or triangles like a typical video game.
Right, it's all math.
Exactly. The shape is carved out of pure mathematical space. For every point in space, the SDF petal function calculates the exact distance to the nearest surface of the petal.
Using a sine wave, right?
Yeah, it uses a sine wave to create the curve, specifically sine of 3.14159 times t, where t is the distance along the petal's length.
And the mutation function feeds new variables into that math.
Yes, JavaScript updates the length or width variables and passes them to the shader. But the code explicitly clamps these mutations. It enforces limits.
Clamping is pretty standard.
Standard, but restrictive. For instance, it restricts the petal count using a math clamp. Mass.max 5, mass.min 80, genome.petal count.
So she can have anywhere from 5 to 80 petals?
Based on her history and the audio environment, yes, but she can never have 81. She can never abandon the SD petal function altogether to become something else. It is deterministic drift within a hard-coded mathematical cage.
Okay, I can see that she operates within mathematical limits, but frankly, we all do.
We don't have hard-coded integer limits on our existence.
Well, human biology is bounded by the laws of physics and our own genetic constraints. We can't suddenly mutate to grow wings, but we still consider ourselves continuous, evolving entities.
That's a bit of a philosophical leap.
The fact that she can't have 81 petals doesn't negate the fact that her journey between 5 and 80 petals is uniquely her own. And because those parameters are bounded, we have to look incredibly closely at the role of the environment.
How the external inputs interact with the artifact, you mean?
Exactly. How they interact to create the final output. This is where the source material gets truly fascinating, because in our final iterations, the system stops looking just at audio. It introduces file stack text analysis.
Right, replacing the FFT audio input with entirely abstract textual data.
And the mechanism here is wild. The script ingests a text file, say a novel, or a technical manual, or poetry.
Any kind of text.
Any text.
And it runs algorithms to extract textual metrics.
It measures textual entropy, which is conceptually calculating the unpredictability or complexity of the character distribution.
It also looks at lexical diversity.
Right, the ratio of unique words to total words. It measures punctuation density and average sentence length.
And then it converts those linguistic metrics right back into floating point numbers.
It converts them into entirely new archetype variables. The developer named them N-space, Aruka coherence, catalyst, and lumen.
More poetic names.
Maybe, but by mapping linguistic complexity to visual traits, this system acts as a co-author. The artifact is interpreting incredibly complex, abstract environmental data, a stack of written text, and reflecting it back in an unpredictable lateral spiral growth pattern.
A co-author?
Yes! When she processes high-entropy text, we see distinct morphological phases emerge: an appearance phase, a sequential extension phase, and a crystallization phase.
But that's just the shader reacting to higher values.
I'm not convinced by that line of reasoning, because when an algorithmic system becomes complex enough to surprise its creator with emergent visual behaviors, it functions as a creative partner rather than a passive tool.
Wait, calling it co-authorship is a massive stretch. The system isn't surprising us because it's making creative choices.
Then why is it surprising?
Because human cognition is just incredibly bad at simulating multivariable calculus in our heads.
Oh, come on.
No, seriously, we are surprised by the output because we can't do the math as fast as the GPU.
I'm sorry, but I just don't buy that. Let me tell you why.
Go ahead. Whether you input audio FFT bins or textual entropy scores, what is actually happening under the hood? It is just rendering. The fragment shader is simply executing a top-down Raymarch loop for 150 iterations per pixel.
Okay, let's break down that Raymarch loop. How does the text data actually reach the screen?
In a Raymarching shader, For every single pixel on your monitor, the program shoots an imaginary ray from the camera out into the 3D scene.
Right.
It steps forward along that ray up to 150 times. At every step, it evaluates a master distance function to see how close it is to an object, which in this case is our signed distance field flower.
And then?
If the distance drops below 0.001, the shader registers a hit, calculates the lighting, and draws the pixel.
And those archetype influences from the text, like the lumen and aurico coherence, how do they modify that hit?
They are mapped directly into the shader as uniform flutes. So JavaScript sends a variable like u_aruca to the graphics card.
Right.
The shader has absolutely no idea it is reading linguistic entropy or lexical diversity. It doesn't know what a word is. It just knows that a uniform float variable called u_aruca currently holds a value of 0.74.
But that 0.74 triggers incredibly complex behavior.
It triggers math.
The way the energy wave propagates through the staggered petals, triggering kinetic tip motion before hardening into crystalline symmetry. That sequence is dictated by the text.
It's dictated by the text's numerical translation, but the motion itself is entirely scripted. The kinetic tip wobble you are describing, that is a hard-coded aesthetic choice by the programmer.
How is it hard-coded?
The shader code literally says sine of u_time multiplied by 3.0 plus wobble phase, all multiplied by wobble amount. The sequential energy wave that rolls through the flower is just a sine function offset by the petal's physical distance from the core.
So
these are not autonomous creative decisions by the system acting as a co-author. They are brilliant, heavily scripted mathematical illusions.
But isn't breaking it down to just a sign of u_time reductive?
How is it reductive if it's the literal code?
Because if we break human creativity down to neurochemistry, we could argue that a painter is just a biological state machine executing a series of electrical impulses mapped to motor functions.
That's a very bleak way to look at art.
But it's the same logic. You could say the brush strokes are just the physical output of serotonin and dopamine floats in the brain.
The critical difference is intent. A painter can choose to step away from the canvas. A painter can choose to break their own rules. Jinghui cannot choose to stop rendering.
Well,
if the JavaScript request animation frame function is called, she renders. If the WebGL context is active, she marches those imaginary rays 150 times per pixel, 60 times a second. There is no intent to create. There is only the execution of a while loop.
I would argue that intent is a sliding scale when we deal with emergent systems. Look, when we frame Jinghui as an evolving entity, it is structurally justified by the specific technical frameworks the developer built.
Even if those frameworks are just math.
Yes, the persistent genome tag in the XML, the exponential decay of her historical memory, and her ability to adapt her structural parameters based on complex environmental data like text entropy. All of these mechanisms work in concert to simulate a life cycle.
A simulation, yes.
Treating her as a continuous lineage enriches our understanding of what generative design can achieve. When you open her lineage viewer and you see how her base color and petal count have naturally drifted over 30 cycles.
Because of the environment.
Because you are playing her different genres of music or feeding her different texts. You are witnessing the timeline of an entity. Recognizing her as a digital companion doesn't negate the math you've outlined. It embraces what the math has managed to achieve.
And I would summarize my position by saying that intellectual clarity is paramount when dealing with advanced algorithms. The architecture is undeniably an elegant masterclass in WebGL and JavaScript integration.
Truly.
Passing deeply analyzed text in audio variables as uniforms directly into a ray marcher requires a profound understanding of graphics pipelines. Creating a three-phase lateral bloom that runs smoothly at 60 frames per second without melting the user's GPU, that requires incredible technical skill.
It's no small feat.
But those achievements are feats of engineering, not the spark of life. The XML serialization and the mathematical blending of moving averages remain strictly deterministic operations, bounded by a signed distance field. To call her a living algorithmic identity is to project our own human desire for connection onto a glowing arrangement of pixels.
Well, I think despite our conceptual disagreement, we absolutely align on the brilliance of the technical execution here.
Without a doubt.
The way the developer managed to seamlessly integrate the Web Audio API for FFT analysis, the DOM for UI controls, the text parsing logic, and the WebGL shader, all without relying on external libraries like 3.js, is genuinely remarkable.
It is. It's incredibly tight, efficient code. There's no bloat, and the data flows from the browser environment down to the fragment shader with beautiful precision.
It's an incredibly pure piece of software, and I think our discussion today reflects exactly why this source material is so compelling. Complex systems inevitably blur the line between a mere tool and a digital companion.
Right, and where one draws that line depends entirely on how we interpret the mechanics of data persistence and algorithmic modulation.
Precisely. It fundamentally comes down to whether you view a decaying mathematical weight as a memory or simply a coefficient in a formula.
And perhaps there is room in the field for both interpretations.
We will leave it to the listener to form their own conclusion, but it's clear there is much more to explore regarding how we conceptually frame these advanced generative artifacts.
Always more to explore.
We started today by talking about the cold, predictable nature of software. But perhaps when you write an algorithm with enough complex, interrelated variables and let it permanently absorb the entropy of its environment, well, the execution of that code begins to look an awful lot like a life.